Welcome to the UVU CS3060 Lecture 0.8, in which I demonstrate debugging using the GNU debugger, or GDB. So let's get started. So here I am in my shell. I am currently working in the ASSN1 directory. I've made a few changes in here, especially within the source code file, if we take a look at that. Now my main function is actually calling a print first character function with this file name variable, and the file name variable has been initialized with argv sub 1. Up here, print first character does exactly what you tell it to. It prints the first character in the string at element 0. So let's go ahead and make this. Let's give it a try. So I'm going to go ahead and run an ASSN1 with numbers.txt, and it does exactly what I hope it does. But if I try running this without any parameters at all, it produces what is called a segmentation fault. This error means that my program was trying to access memory that it wasn't allowed to access. Now, whether the memory was off limits or whether the memory just simply doesn't exist, it could be either one. So we want to debug this program, but before we debug it, we need to make sure we have debug symbols. And those, in this particular project, are set within the make file. This make file is a set of rules that are used to build certain files. So inside the make file, the first couple of lines are basically setting what are called macros. These are like variables, but these macros come along and are replaced in certain places with my file. So ASSN underscore name will be replaced with ASSN1. This way I only need to change one macro, and this would be changed in 6 different locations throughout my file. There are 3 sections here. Each section has a particular format. The format starts at the left edge of the file and starts with what is called a target. Now, a target is the name of a file that is checked, and if that file doesn't exist, or if this file is older than everything after the colon, these are called dependencies, then what happens is make executes each indented rule after that target, and it has to be tab indented. Now, each rule is executed within the shell in hopes of potentially generating the file. In this case, for the ASSN1 target, it will run the compiler with these C flags and this source code file to output the executable. Now, what are the C flags? That's actually what's important here. There are actually 3 C flags here. The -G, the -O2, and the -WALL. It's the -G that matters to us. In order to use the debugger, we have to have included in our executable debug symbols. Those debug symbols are added by the compiler when the -G option is present. So in this case, I verified -G is present, so we should have debug symbols in our executable. Let's go ahead and debug it. So I'm going to run GDB with my executable. Now, there's lots of output here, but down here at the very bottom is exactly what we're looking for. It says it's reading the symbols and that it was successful. So at this point, let's try our first debugging command. We're going to run the program, and what this does is it starts the program and allows it to finish as long as it doesn't hit a breakpoint. You can put any number of arguments after run, just like you can put any number of arguments after the /ASSN1 on the command line. It's exactly what they are arguments. So if I run with numbers.txt, it runs like what we expect. It prints out the first character, and the string is n. So I'm going to clear the arguments and try running it with no arguments now. And at this point, it fails on me. It fails at line 14 inside the function print first character. Aha, we found our problem. Well, the problem here is very likely in one of the variables, and there's only one variable that's being used on line 14, and that's the str variable. So I'm going to print str, and it comes out as 0. Well, I wonder what this variable should look like. So let's set a breakpoint at line 14. That is done by doing b space and then the line number you want to set the breakpoint at. Now I can go ahead and run it, but let's run it with numbers this time to see what a real answer looks like. Yes, start it over. So at this point, we reach the breakpoint, and if we print out, let's go ahead and step into that. There we go. Not certain why it broke outside of it. Oh, I know exactly why it broke outside of it. But let's go ahead and print out stir. And you can see now stir is set to a value of numbers.text. So it's exactly what we expect it to be, not the 0 that we saw up here. Now, there is an important command that allows you to see the different function calls that were made. It's called backtrace, or BT. If you type BT, it shows you a list of the different calls that are made. It starts at the current one, where you're at, level 0, and then goes up. Main has called print first character. So you can see the steps that were taken to call various functions. We can now list, if we want to, we can go up to the main and go ahead and print file name. And it shows us that file name is also the same value as stir, the parameter we passed in. There's also another command called examine. And you can use examine to examine pieces of data. And it looks the same as print, but examine gives us a lot more flexibility. Maybe I want to examine 8 characters of file name. And it will actually print out the character values for each byte within my character string, or at least the first 8. If I want to do 16, I do 16 characters of file name. And you can see it does numbers.txt. There's the 0 that terminates my string, and then garbage afterwards. Well, now that I know where that particular error is, some other things I can do. There is the command info locals. Info locals shows me all the local variables that are defined within my particular stack level. Remember, backtrace lets me see what the stack levels are. If I go down the stack, back to the print first character, if I go ahead and do info locals, it says there are no local variables, although I disagree with that because there's stir. The problem we're seeing here is I've optimized out a lot of things. If I want to change the optimization level, I would do that in the make file. Now, with all this, I'm going to go ahead and enable a text user interface. I've been showing you commands, but there is actually a nifty little text user interface that is provided by GDB. If I choose to clear my args and run it from the beginning, it'll show where that breakpoint is. Let's say I want to delete that breakpoint. Well, if I do info breakpoints, it shows me the breakpoints that exist inside my program. There's 2 breakpoints here. There's a 1.1 and a 1.2. I'm going to delete the 1.1. Let's delete 1. There we go. And if I do info breakpoints, there's no breakpoints at this point. So let's go ahead and run without any arguments. And it shows you where that segmentation fault is. There are various layouts you can use. You've got registers where it will display the actual system registers that are being printed. So you've got that. You've also got an assembly layout where it actually shows you the assembly code and exactly where the failure happened in the assembly code. So lots of options when it comes to the TUI. If you want to get rid of, if you run it, a lot of times if the program has output, it really screws up the screen. You can see lots of broken lines, things overlapping. Just press Control L and it refreshes the screen. So at this point, if I want to get out of the TUI, it's TUI disable. And I'm back to just the regular command line. So these are some of the things you can do with the GDB debugger. When you're done using the debugger, just type quit and it will exit out. It may say, do you want to exit with the running process? Feel free to do that as well. In fact, let's go ahead and see that in action. Remember, if I just simply type run, I'm going to hit a segmentation fault. If I go ahead and say quit, it's going to ask me, do you want this process to be killed? Yes, I do. And there it is. Thank you very much. Appreciate your time. I hope this video was very useful to you.